So good morning, my name's Dominik, and my partner Patrick and I will be explaining our problem today. Okay, so for question number 2 for our project, it was if one individual bought 20 tickets, what is the probability of winning exactly 9 prizes? So for this question we did the formula P equals NCX times PX times 1 minus P exponent N minus X. For a number of trials, like mentioned in the question, it was 20. See, 9 is the number that we're trying to find in total. 40 is our percentage to the 9. Then we go times 1 minus the 40%, and then our exponent again is the 20 minus 9, which comes from here. So after we do those, punch those in the calculator, it gives us that. We multiply those 3, and our percentage is 0.159651. And if we round it up to 2 decimal places, it's 0.16. So for question 2, if he bought 20 tickets, the probability of winning exactly 9 prizes is 0.16. Whenever you're ready. So for question number 3, it asked, if one individual bought 20 random tickets, what is the probability of winning more than 17? And just to keep in mind, we do have a 40% chance of winning with each ticket. So this one's asking for more than 17, which means you would have to calculate for 18, 19, 20, and then add them up. So just like question B, the formula is the same here, the one we learned in class. So down here I did it for 18, I added all the numbers, 20 tickets, 40% chance with the same formula. That's what it gave us. I used the same formula for 19 tickets, gave us that answer, and the same formula for 20 tickets, gave us that answer. And the final step for that was adding the 3 answers. So 1, 2, 3, we added them up, and the probability of winning more than 17 is 0.0000516. Okay. So question number 1 asks, why does this situation represent a binomial distribution? So our question, just to repeat, was sponsors of a local charity brought tickets for various prizes with a 40% chance of winning with each ticket. So it does represent a binomial distribution because it has all the requirements as we learned in class. So the first requirement was an outcome on each trial of experiment is classified into 1 or 2 mutually exclusive categories, a success or failure. So in our case, it's either going to succeed, meaning he will get the prizes, or he won't. The second requirement was the random variable is the number of successes in a fixed number of trials. So our fixed numbers are given with each question respectively. So for question 2 it was 9, for question 3 it was more than 17. The third requirement was the probability of success is the same for each trial. So our probability was 40% for each trial, so it was indeed fixed. And the final requirement was the trials are independent of one another. So our question 2 was not correlated to question 3. Therefore, they were independent of one another.